Hey, it's Mr. Hayashi with Geometry 2.4 notes. For 2.4, it's algebraic reasoning, or kind of what you did all last year, solving algebraic equations. Your teacher, I'm sure, made you show all of your steps, but now we're justifying or giving a reason for each of the steps. Before you give a reason for each of the steps, you need to know each of the reasons. So we'll review some of the properties of equality here, and then other properties that you'll use for reasons or justifications for your algebraic reasoning, or I call them algebraic proofs as well. So I'm going to go through these pretty quick. They should be pretty basic and easy. It's what you used, again, all the last year when you're solving any algebraic equations, and we've used them already this year as well. So some properties of equality, or algebraic properties of equality. Instead of writing out the addition property of equality states whatever you do to one side of the equation, whatever you add to one side of the equation, you could add to the other side of the equation. I'm just going to go through an example instead of writing that out. So an example of that would be something like solving x minus 5 is equal to 18. So you know that you could use inverse or opposite operations here. You actually would be using the addition property of equality, adding 5 to each side of the equation. That's using the addition property of equality. Whatever you add to one side of the equation, you have to add to the other because everything balances out. And then the same is true for the subtraction property of equality. Sorry, I'm going to be kind of all over the place here because I didn't leave myself enough spacing. But subtraction property of equality states whatever you subtract from one side of the equation, you have to subtract from the other. So something like this, x plus 2 is equal to 7. Notice for that last equation, I didn't write the solution. The solution would technically be x is equal to 23. But I just want to show you the addition property of equality. Just like on this one, subtraction property of equality states whatever you subtract from one side of the equation, you subtract from the other. So that's using right there the subtraction property of equality, subtracting 2 from each side of the equation. Multiplication property of equality states you multiply by the same thing on each side of the equation. So for example, say b over 3 is equal to -4. So since b is divided by 3, the inverse operation is multiplying each side by 3. And that's using the multiplication property of equality. Division property of equality, as you could probably guess, whatever you divide on one side of the equation, you have to divide on the other side of the equation. So something like 2m is equal to 14. To solve this for m, you divide each side by 2, and that's using the division property of equality. Substitution property of equality, say you come up with the solution. So on this first example here, the solution, as I mentioned, would be x is equal to, it's supposed to be 18, so 18 plus 5, 23. To check this solution, you could substitute it back into the original equation. So substitute in 23 for x, and then 23 minus 5 is 18, so that solution checks. That's using the substitution property of equality. And then the distributive property states whatever is outside a set of parentheses, like 5 times a quantity x minus 1. I can make this an equation if I wanted to and solve it, but distributive property states whatever is outside a set of parentheses, you can multiply it by each term inside the parentheses. In other words, distribute whatever is outside of the parentheses to each term inside the parentheses. So I would end up with 5x minus 5. That's specifically using the distributive property. So those are properties of equality that you could use for your algebraic reasoning once we actually do go over examples of that.